This is a tutorial for TomZ's 4x4x6 cuboid. It's a little messed up right now, but you want to make sure that when you're scrambling this, you want to scramble it in its correct shape first. And after you do that, then you can start scrambling the shape as well. And that is because when you mix it like this, these pieces that are popping out, they cannot turn anymore unless they're completed. So you just want to mix up as much as you can before you mix up these. Okay, so now I'll start scrambling the shape. Okay, so now it's scrambled. And the first thing I want to do is to solve it as a 4x4x4. So as you can see, although there are other pieces that are popping out in these gaps in between where they pop out, there will always be a 4x4 square on every face. And so for the first part, you can solve it like a 4x4x4 exactly. So, like this one is already completed while I was scrambling, but you want to solve these centers first. So this one's already completed. Opposite of this goes green. Like that. And then there's white and yellow that go opposite of each other. So now I have blue and green and white and yellow. Well, first I have to move it over here to make sure they're opposite of each other. So now I'm done with that, and the last two centers are this red and orange. And right now, there is a possibility that this orange and red have to be flipped, but unless if you memorize the configuration, you just have to wait until a bit later. And the way to flip it is actually pretty simple, so you can just solve everything else first. So now I'm still going to solve like a 4x4x4, and I'm going to solve these edge pieces. The ones that bulge out will always match with each other, and this piece that goes inside, like this one, this white piece, it will never be a piece like this green and white or this blue and yellow, where there are still edge pieces but do not pop out. And so I'm going to solve them like a 4x4x4, which you should know. But in case you don't, you start off like this, where there are one of the pieces you're going to solve and the other piece directly opposite of it on the top face, and it should be on the other side as well. For example, this one's on the left and this one's on the right. And so what I'm going to first do is to bring this one down here to match them. And since the centers have to go back up, before I move it back up, I want to replace this green and orange with another piece. And since this orange and yellow is a piece coming back up, I also want to make sure the orange and yellow piece, this one, comes right here, just to speed the solving process quicker. Like that. And you just keep solving like that for now. Blue and yellow. Here's the green and white. Oh, and there's also situations like this where both pieces that you want solved are actually connected to each other. So both sides have the blue and red, and they also have the red and yellow. So instead of solving it normally like before, because once I do this, I can't replace this with this piece, or else this green and white will be messed up. So instead of doing it like that, I want to flip this around first. So now I want to have them directly opposite of each other on the top face. Blue, red, red, yellow, and they should always also be on the same side. Both the blue reds are on the right, and the red yellows are on the left. Now from here, I'm going to solve it normally, as I usually do, except I'm going to take this out through the front face like before, but instead of putting in a different piece through the front face or the top face, I'm going to take the same piece and put it in through the top face, and taking it out through one face and putting it back in through the other will make it flip around. And once it's flipped around, when I bring this back up to solve the centers, the blue and red and yellow are solved. And it looks like these two are the last pieces, this green and yellow and blue and white. And since they're both the same pieces, I'm going to do it like I just explained. So put them in opposites, take it out one way and put it back in the other. And now all the edges should be solved. So now from here, I'm going to solve like a regular 3x3x3. I'll start with the red side. And this is where you can tell if the red and orange are on the correct sides or not. When you put in any of the corner pieces onto the red or orange side correctly, you'll be able to tell if these two connect as well as this red. That means it's on the correct side. But if it's on the incorrect side, then they should be flipped. So the white would be here and the blue would be here. So since it's not, it's in the correct spot. But if it was not, all you have to do is to rotate 2R, 2 layers in, 2U, 2R, 2L, 2U, and 2L. And that would swap it. But since it's not, I'm going to put it back as it was. And I'm going to continue solving it as a 3x3x3. And there's also this kind of problem that occurs. It also occurs for the 4x4x4, and this is where only 1 or 3 of the edge pieces on the last layer is flipped around the wrong way. Usually there's only 2 or 4, or none at the most, or at the least, that have to be flipped, but in this case there's an odd number. So what you do for this is you start with that piece in front, or you can start with any piece, but it's better to start with the front because then you won't have to do any other algorithms. So start with the piece in front. You're going to do 2R, 2 layers in, 2B, 2U, so 2R, 2B, 2U, L, 2 layers in, 2U, R inverted, 2 layers in, 2U, R, 2 layers in, 2U, 2F, R, 2 layers in, 2F, L inverted, 2 layers in, 2B, and 2R, 2 layers in. And that should solve your problem. So now I'm just solving it as best as I can, like a regular puzzle. Now there's other problem that occurs when there are two corners that are flipped in the wrong place, while all the other corners are in the correct spot. And for that one, you want to start with the blue, white, green, or yellow. You can start with the yellow. And what you're going to do is to basically swap these two pieces with these two pieces. So first I want to bring this one up to this side while keeping this side up here. So I'm going to rotate the middle two layers like that. Take this yellow off to the side somewhere and put it back in. Now from here, I want to have one of the yellows on the front, the other on the right. Now this algorithm is going to swap these two. So it's going to be 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And you might have noticed, as I was saying U, I only meant this layer, this inner layer. That's because this algorithm was originally derived from a 2x3x3 or 4x3x3. And so, especially for the 2x3x3, the U would always be that one layer, and there's no inner layer, so the U would always be the top layer. But in this case, the U is this inner layer right here, right about the center. And now I'm done with that, so I'm going to rotate this back as it was and put it back in exactly as it was before. That should keep all the center solved. And you may have noticed it also flips around these two though, as well. And now from here I'm going to solve this orange side again, as I was doing before. And once I solved it, it should turn out normal. And as you can see, all the corners are in the correct spots now. Now, next thing I have to do is to solve these inner edge pieces in this middle layer. And to do that, I want to first see how many pieces actually have to be swapped. There's 3 up here and 3 down here. So first I'm going to have them opposite of each other in a way that when I rotate these two layers like this, there will be at least 1 or 2 of them that are actually solved. And I also want to make sure that there's another piece that's not solved off to the side like this. So first I'm going to rotate it like that. And next I want to swap this green, this solid green, with another piece that's not solved, so that when I put it back, this will not mess up again. So I'm going to swap these two, using that same algorithm as before. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And from there, I'm going to flip it around again. And you may have noticed it swaps this around. For now, all you have to do is just rotate it again. And now there's 2 up here and 2 down here. So I'm going to do the same thing as before. And in this case, there's only this piece that has to remain. So that means that once I swap it, I just have to make sure that this piece and this piece stay as they are, but I can do whatever I want with these, this one and that one. So first, like before, I'm going to rotate it into a position where after I swing it around like that, it's actually going to solve something. And in this case, I'm going to swap this white out with this piece. So same algorithm again. Now from here, I'm going to rotate it around. And now there are only these 2 pieces that have to be switched. Now what I'm going to do is to have one of them on this layer and the other one on the bottom layer. And from there, I want to have them directly opposite of each other. So one here, and when I swing it around, the other one here. So now when I flip it around, these 2 will be mixed up like that. It will be solved, I mean. And another thing I want to make sure of is that there's going to be one of a specific color here on the side, and the same color onto the side of this other layer. So when I swing this around, this white comes over here, and there's also a white here, so I can use these 2. And right now, this green and this green are the same, so even if I flip it around, they will remain solved. But this yellow and this blue will not. So I'm going to swap this green with this white. No, not the green. This blue with this white, and this yellow with this white. So I'm going to start here and do the same algorithm that I mentioned earlier. And put it back as it was. And I'm going to do it again with this white and this blue. You just have to make sure that since this one is flipped, I want to make sure I use this as the right side again. Like that. Now when I rotate this around, all the edges in these inner layers will be solved. Now all that's left to do is to solve these 2 inner layers as you would a 2x3x3 or 4x3x3. And so first I want to solve all the corners. I have to see which ones actually go where, which layer. These 2 are correct, and these 2 are also correct, because when I move it here, this one solves. When I move it here, this one also solves. In some cases, they have to be flipped according to their layers, but in this case, you don't. So from here, what I want to do is to swap these 2. I want to flip them around. And to flip them around, I want to have the other 2 pieces that are not solved off to the left, and these 2 to the right. And from here, I'm going to do 2R, U as in this inner layer, U, 2R, U inverted, 2R, 2F, U inverted, 2F, D, and 2R. And as you can see, that solves these inner layers, these corners. And I'm going to do the same thing here. these two are good, and these two have to be flipped. Same exact algorithm. Next, I want to see if any of these edge pieces have to be flipped with another one on the bottom. In this case, they're all already on the correct layers. Well, not necessarily each specific color, like this yellow and this yellow might have to switch or something, but other than that, they have each of the same color, each of a different color on each layer. So I'm going to start here. I'm going to swap these two using that algorithm I mentioned before. And I'm done with that one. And again, this one flips around like this, so I have to make sure I use the same side as the right side. So now I'm going to swap this yellow with this blue. And they're directly opposite of each other, which is a much simpler algorithm. So I'm going to do 2R, 2U, 2R, 2U, and 2R. And now there's only these two left. But in a case where there's only one of the algorithms having to be used, as you noticed earlier, these two and these all flip around, while only these two layers are solved. So that means that these two whites have to be switched, these two blues have to be switched, the yellows or the greens have to be switched. So I'm going to start with white, and the same exact way as I solved this error where I flipped these two, I'm going to do the same thing with these layers. So I'm going to have them both here, like that. So now both whites are on the same layer. I'm going to have one on the front, one on the right, and use the algorithm to swap them. And now put everything back as it was. And now, once I do the algorithm to swap just these two, so that the blue will come here and the white will come here, everything else will come back to normal. All of these will flip over. So using the algorithm one more time. And that's how you solve TomZ's 4x4x6 cuboid. Thank you for watching.